What type of braking system is used in an electric vehicle? Are there any differences between the conventional vehicle braking system and electric vehicle braking system? Today we are going to discuss about the regenerative braking in an electric vehicle. The most common type of brake system is friction braking. The kinetic energy of a moving vehicle has to be dissipated into another form to stop the vehicle. A friction brake is used in a conventional vehicle to stop the vehicle. When we apply brake to a conventional IC engine vehicle, the kinetic energy will be converted into heat energy in the brakes and it stops the vehicle. In general, we will not reuse the energy that dissipates as heat energy in a conventional vehicle. Drum brake is an example for a friction braking system. In an electric vehicle, there is a chance to use another type of braking system also. It is known as regenerative braking. The machine that drives an electric vehicle can act as a generator as well. For example, a DC motor or induction motor can act as a generator when its shaft is rotated by an external torque. When we drive the electric vehicle, the machine uses the energy stored in the battery. Using this energy, it rotates its shaft and moves the vehicle. To stop the vehicle, simply I would say we stop the supply to the motor. Don't get confused here, the motor rotates in the same direction during driving and braking, but the machine acts as a generator and the torque will be negative during braking. Assume that we are using a DC machine in an electric vehicle. In that machine, when the back EMF is greater than the terminal voltage, it flows current from the machine to the supply. Assume that the vehicle is being driven at a constant speed. What will happen if we simply disconnect the supply to the motor? The vehicle will very slowly decelerate. The aerodynamic drag and the rolling friction are the forces that act on the vehicle during that time. The deceleration of the vehicle will be very slow. To stop the vehicle, we can either apply friction brake or regenerative braking. If we can make sure that the voltage at the terminal of the motor is less than the back EMF using the controller and provide a path to flow the current, it will convert that kinetic energy to electric energy and it flows the current through the closed path that we provide. The closed path will be through the battery and the battery will be charged. Now we just disconnected the supply to the motor. What happens if we connect a resistance across the terminals of that machine? The machine is now rotating by the kinetic energy of the vehicle. It generates electricity and it flows the current through the resistance and it dissipates the electricity as heat energy. This kind of braking is known as dynamic braking. Sometimes dynamic braking is used to heat the interior of big vehicles such as truck and trams. In the case of regenerative braking, instead of these resistors, we are connecting the battery itself to the motor. The controller makes sure that it operates in such a way that the terminal voltage is less than the back EMF of that DC machine. Hence, we can store the kinetic energy that would have been lost as heat energy in the battery. This is the simple concept of regenerative braking. This is applicable for PMSM motors and induction motors as well. Now let's check out the advantages, disadvantages and how effective would be regenerative braking in electric vehicles. Various studies show that it would be possible to recuperate around 60 to 70% of kinetic energy during braking. It doesn't mean that it will improve the range of the vehicle by 60 to 70%. It stores 60 to 70% of kinetic energy that would have been lost as heat energy during braking. Regenerative braking is effective in drive cycles that have a lot of stops and decelerations. The factors that affect the effectiveness of regenerative braking are the terrain, driving conditions, size of the vehicle, and SOC of the battery, etc. A regenerative braking alone cannot stop the vehicle completely. To bring the vehicle to complete standstill, we have to use friction braking as well. At very low speeds, the regenerative braking is not that efficient. So an electric vehicle uses both regenerative braking and friction braking together. In case of the battery is fully charged, the regenerative braking will not be efficient. It cannot store further charge on the battery. So friction braking is also necessary in an electric vehicle. The regenerative braking improves the life of friction braking system. It could reduce the frequency to apply the friction brake. Another advantage of regenerative braking system is that it enables single pedal driving in an electric vehicle. We have a video about the single pedal driving, don't forget to watch it out. In an electric vehicle, there is not many additional equipments to be installed to enable regenerative braking. It is a property of the machine itself. The size of the vehicle is an important factor that affects the effectiveness of regenerative braking. Big vehicles have higher potential to recuperate more energy. Thank you so much for watching this video. Subscribe to this channel for more interesting videos.